Okay, so today's lesson is going to be on solving rational equations. It's in the next section of our printed note package that we didn't quite get to before the school lockdown. Anyway, here we go. So again, we're going to start today with just a review of adding and subtracting rational expressions. That's what we've spent the last couple of days working on. And then we're going to introduce a new concept called solving rational equations. So this is where you have a bunch of rational equations that are set equal to each other, and you have to solve for the value or values of x. You're going to find that this is where NPVs start becoming especially important when you're trying to solve what the actual value of x is that would make an equation true. But we'll get to it when we get to it. So let's get rolling. So first one that's in our notes as a little bit of review for subtracting rational expressions is this one right here. I want to remind you when we tackle adding and subtracting rational expressions, we should always start by factoring everything that we can. So first things first on this one, if we're going to factor this, notice the numerators of both of these are just fine, but we can factor both of the denominators right here. So let's start with that. 2 over this guy right here, well, that denominator of x squared minus 4 is a difference of squares. So to factor a difference of squares, remember you take the square root of the first piece, take the square root of the second piece, and just multiply them as conjugates. So in other words, the square root of x squared is x minus the square root of 4 is 2. And then you multiply it by the same thing, but as a conjugate. So x plus 2, that's the conjugate. Minus 7 over this whole thing right here. Well, this is just a classic sum product rule. So we're looking for two numbers with a sum of 5 and a product of 6. Well, those two numbers are going to be 3 and 2, positive 3 and positive 2, I should say. So x plus 3 is going to be one of them, and x plus 2 is going to be the other. Now, the next step when you're adding or subtracting rational expressions, just the same as when you're adding or subtracting normal fractions, is that they need to have the same denominator. Well, having it all factored is actually going to help us out quite a bit, because once it's in factored form, you can start seeing what things they have in common versus things that they don't have in common. Well, one thing that they have in common right now is this x plus 2. Both of those fractions right there, or those rational expressions, I should say, they both have x plus 2 as a factor in the denominator. However, this one on the left has an x minus 2 that this one doesn't have. And the one on the right has an x plus 3 that the other one doesn't have. So really all you have to do to get around that is we'll take this x minus 2 and make sure we put it on the denominator of the other one. But of course, if you're putting it in the denominator here, you also have to multiply the numerator just to keep that second rational expression equivalent to what it was in the first place. And then likewise, we should also deal with this x plus 3 by giving the one here an x plus 3 on both the top and the bottom. So by doing this, we've now forced both of these rational expressions to have the same denominator. And you might be saying, oh, well, they're in different orders. When they're all factored, multiplication does not matter, or with multiplication, order does not matter. So in other words, the fact that they're in different orders is just fine. So what I'm going to do is I'm going to write this as one single fraction first. So I'm going to say that this is 2x plus 3 minus 7x minus 2, all over the same common denominator of x minus 2, x plus 2, and x plus 3. So this is where we're going to have to start cleaning up the numerator here. I would advise double dipping each of these through. There we go. So this is going to become, in brackets, 2x plus 6 minus, in brackets, 7x minus, not minus 2, whoops, got carried away. 2 times 7, of course, is minus 14. Once again, all divided by x minus 2, x plus 2, and x plus 3. And last but not least, we should simplify this. Remember, we're subtracting a binomial here, so this is going to make it minus 7x, but then this minus has to also hit this minus 14, so it'll make it plus 14. And that'll allow us, you know what, I'll just write it all out. I'll just say 2x plus 6 minus 7x plus 14 all over x minus 2, x plus 2, and x plus 3. You can tell I'm getting tired because it's quite tedious on this one, but anyway, here we go. So 2x minus 7x, that's going to give us negative 5x. Plus 6 plus 14 is plus 20. And that is all over x minus 2, x plus 2, x plus 3. Now there's one more thing you could do here. You could factor the numerator by bringing out a negative 5 on both of these. But what you're going to find it's going to do is it's just going to change it from negative 5x plus 20 to negative 5 times x minus 4. And that doesn't actually do anything, right? Because there's nothing you can do with this x minus 4. While it is factored now, it's not going to cross out with anything on the bottom. So there's not really a reason to factor it. So if you didn't change it to this, that's fine. Either way, though, this or that answer I had there before was negative 5x plus 20. Both of those are just fine. They're totally correct answers. However, we cannot forget we have to list our NPVs. This is kind of just our fail-safe to say, hey, it doesn't always work every single time. Our NPVs in this case are going to be x can't equal positive 2. That's because of this guy. That would make this piece equal to 0. As for this x plus 2, that'll be x cannot equal negative 2. And then as for this x plus 3, we have to say x can't equal negative 3. All right, moving on to the next one. I'm actually going to advise you guys pause the video here and give this one a try on your own. Don't worry about bleeding into the next one. That next example right after this in your note package, we're just going to skip because we don't need to be covering anything quite that advanced when we're doing online stuff. So anyway, pause the video here, give this one a try on your own, and I'll go over it in just a second. All right, so now might be a good time for me to go over this. Hopefully you were able to get this one figured out. First things first, so we got to factor everything. The numerators once again look just fine. So I'll leave 4x just on its own. But x squared minus 5x plus 6, we're looking for two numbers with a sum of negative 5 and a product of positive 6. Well, that'd be negative 3 and negative 2. So x minus 3, x minus 2. And we're adding this to 5 over 3x minus 6. Well, the only thing we can factor there is take out a 3. So it's 3 times x minus 2. So now we just look at our denominators and think, okay, what pieces do we have in common? We have this x minus 2 in common, so that's all well and good. But this one on the left has an x minus 3 that the other one does not. So I'm going to put an x minus 3 on the top and the bottom of this other one. And then last but not least, they now both have that x minus 3. Last but not least, they both need this, positive 3 right here. So I'm going to multiply the top of this guy by 3 and the bottom of this one by 3 as well. So if we're going to clean this up a little bit, 4x times 3 on the top there is 12x over, I'll bring that 3 out in front just because I think it's a little easier seeing it there. So 3 times x minus 3 times x minus 2. And you know what? I'll write this actually as one giant fraction. Might as well save us some time here. We're adding 5x minus 3, so I'll even just write plus 5x minus 3. You could have double dipped it through right there because it's an addition and it's not going to change the signs or anything. Either way you do it though, this 5 is just going to bounce through this, so we'll have 5x minus 15. So of course 12x plus 5x will be 17x, and then minus 15 all over 3 times x minus 3 times x minus 2. And then this is where things are kind of funny. If you look at the numerator here of the answer, 17x minus 15, there's nothing that actually factors out of that. So in other words, there's nowhere else for us to go. And even this 3 on the bottom, it's not going to divide anything up on the top here. Certainly since we weren't able to divide anything out to factor it, it definitely won't be crossing out anywhere. So in other words, 17x minus 15 over 3 times x minus 3 times x minus 2, that actually is as uncomfortable as it is. That's our final answer. But of course, we do need to list our NPVs, and there's only a couple here. 3 is never going to equal 0, so we don't have to worry about listing that as an NPV. But x minus 3 will equal 0 if x equaled 3. So we have to say x can't equal positive 3 because of this guy in the middle here. It has nothing to do with this 3 out here, right? 3 will never equal 0. We just have to look at each individual factor. But x minus 3, this one right in the middle, will equal 0 if x equaled positive 3. So we have to say x can't equal 3. And then as for this other one, x can't equal positive 2. And that takes care of our NPVs. All right, this next one, as I mentioned just a few minutes ago, we're not going to do this one, right? If you're curious what the answer is, or if you want to try it on your own, by all means, go for it. But the answer is in the answer key that I've posted on Google Classroom. You don't need to worry about this, though. There's no point in doing anything quite this challenging when we're going to be doing the rest of this unit online as is. Anyway, moving on. So talking about the main thing for today, solving rational equations. Hopefully not a big surprise that an equation is just an expression that has an equal signs showing what one side is equal to compared to another, right? So this is just where a bunch of rational expressions are added or subtracted together, or that are added or subtracted together, equal another rational expression, and you're going to be asked to solve for x. So in other words, if I have a rational expression equal to another rational expression, you have to tell me what value or values of x would make that true. That might sound a little daunting. And believe me, at first glance, they are. But the strategy to solving these is actually very similar to the strategies we've been using just to add or subtract rational expressions together. So to do this, really you just got to follow about 4 different steps. I would start by factoring everything in the equation. That shouldn't be a surprise to you. That seems to be like what we've been doing this entire unit. Just factor everything right off the bat. Then step 2, ensure everything has the same denominator if you're adding or subtracting expressions, right? So just make sure basically everything has the same denominator. Now that's really important because then in step 3, this is my favorite step, once everything has the same denominator, like on both sides of the equation, everything has the same denominator, you can completely ignore it. In other words, the denominator, you might as well just say, you know what, it doesn't exist anymore because they both have the same denominator on both sides. The denominator only contains NPVs, your non-permissible values. So really, you only care about what's going on up in the numerator. So you can just completely ignore the denominator, and then in step 4, you just solve the leftover numerator equation. As usual, though, this is way easier just to see an example. So we'll start with a simpler one, just so you can get the basic ideas down. So we have x over 3 plus 5 over 2 equals 5x over 6. If we go back to the steps, you can see step 1 says start by factoring everything in the equation. Well, this already is factored, right? There's nothing we can do to factor this. There's nothing to pull out of anywhere. So step 1 is already done. Step 2, however, says ensure everything has the same denominator. Well, to get everything to have the same denominator, look at the denominators and think, okay, what can we use as a common denominator here? Well, I think it's pretty clear that 6 would become a really good denominator just by multiplying this guy by 2 over 2 and this guy by 3 over 3. This is going to give us 2x over 6 plus 15 over 6 equals 5x over 6. Since everything is being divided by the same thing, in other words, since all of these have the exact same denominator, you might as well ignore it because there's nothing interesting going on down there. Everyone has the same denominator here. So we can just say, you know what? All of these denominators are gone. A mathematical reason for this is you can just say, all right, remember, whatever you do to one side of an equation, you can do to the other. What if we just times the whole right side by 6? That would mean we'd have to times the whole left side by 6, and that would get rid of it, right? But again, I think it's just easier just to say, you know what, just ignore the denominator. Anyway, what that means we're left with is 2x plus 15 equals 5x. And this just becomes a standard equation to solve. As a matter of fact, this is a linear equation to solve. It's not even a quadratic or anything. So to solve this, we just have to gather all of our x's and solve for what x could be equal to. Personally, I think I would minus 2x from both sides. This is going to give me 15 equals 3x. And then we just have to divide by 3 on both sides. So x is going to equal 15 divided by 3, which is 5. So x equals 5 is our solution. Notice in this rational equation, we never had any NPVs because there's no variables down in the denominator. So x equals 5, that's our solution, and we can be pretty confident that that one's going to work. All right, we're going to do one that's just a little bit more difficult. I won't get you to try this on your own quite yet because I think this will really illustrate what the idea is. We've got a bunch of variables down in our denominators now. Now, always ask yourself, first step, what can we factor? Well, unfortunately, there's nothing to factor here, so that means we basically can just consider each of these denominators already factored, so already their own little pieces. Notice right off the bat, we have x minus 2 on the one on the far left and x minus 2 on the one on the far right. But the one here in the middle has x plus 7. So that's the only one here that actually has a different denominator from the others. We want to make sure that everything has the same denominator. So I think the easiest way of doing this is multiplying this one on the far left by x plus 7 on both the top and the bottom. This one in the middle by x minus 2 on both the top and the bottom. And this one on the far right by x plus 7 on both the top and the bottom. The reason for that is that way this one on the far left is going to have an x plus 7 in the denominator as well to go with its x minus 2. The one in the middle will also have an x minus 2 and an x plus 7, and the one on the far right will have an x minus 2 and an x plus 7. So in other words, they'll all have the same denominator. Let's write this out just so it's a little bit more clear. That was a terrible equal sign. Hold on. There we go. That's better. This is going to be 3x plus 7. There we go. Over x minus 2 times x plus 7 plus 5 times x minus 2 over x minus 2 times x plus 7 equals 2 times x plus 7 over x minus 2 times x plus 7. Since all of these things, all of these rational expressions in this equation have the same denominator, we can just say we can ignore the denominator altogether. We can just completely cross them out here. That means we're just going to be left with an equation that deals only with the numerators. And while we're at it, just to save ourselves some room, before we write our next line, we can just start double dipping things through to expand out these binomials, right? So 3x plus 7, or 3 times x plus 7, I should say, is going to be 3x plus 21, plus 5 times x minus 2 is 5x minus 10. And this is going to equal 2 times x plus 7, that'd be 2x plus 14. Once again, this is just a linear equation to solve. There's no quadratic here. It's not like there's an x squared involved. So let's just gather up all of our x's. I think it's clear to see 3x plus 5x is going to equal 8x on the left side. But while we're at it, let's just minus over our 2x. So 3x plus 5x is 8x, minus 2x is 6x. And then also while we're at it, we'll move over this 21 by minusing it, and this 10 by adding it. So we have 14 minus 21 is negative 7, but then negative 7 plus 10 is positive 3. So 6x equals 3. Again, I just moved all my numbers to the right side and all my x's to the left side, and that's where I'm at. Last but not least, though, we care about what 1x is equal to. So let's divide both sides of this by 6, and we're going to see x is equal to 3 divided by 6, which is just 1/2, or in other words, 0.5. All right, there is one more thing we have to do here, though, and I know it seems redundant, and I know we've just done it this whole time, but we need to list our NPVs from this question. The good news is not very many NPVs. If you look back at the original thing, or even in the second step, the only NPVs we have are x cannot equal 2 and x cannot equal negative 7. The nice thing is, though, with these NPVs, our final answer of 0.5 is not one of those two NPVs. So in other words, we can kind of rest assured that our final answer of 0.5 will actually work. But again, if you're never totally sure about it, you can always plug it in and test it. I wouldn't worry about it because it will work as long as you've done the math correctly. But again, I guess that is a good way of checking your work. All right, looks like meat's back on the menu, boys and girls. We've got something even more hefty here. Just for fun, I would actually suggest you guys pause the video here and give this one a try on your own. The only reason that this one's a little beefier is because of this polynomial right here. But I feel pretty confident you'll be able to get this one on your own. Anyway, pause the video here, write small when you do this in your notes, but we'll go over it in just a second. All right, I'm going to go over this one now. First things first, of course, factor everything. The numerator here, 5x minus 1, nothing pulls out of that, so we'll just have to leave it as 5x minus 1. The denominator, however, classic sum product rule. We're looking for two numbers with the sum of 1 and a product of negative 12. Well, that's going to be positive 4 and negative 3. So in other words, we'll write that as x plus 4 and x minus 3, which, just by the way, if you looked at the denominators of the other two fractions, probably a pretty good hint as to what was coming. But anyway, let's say this is add 3 over x plus 4, and that equals 1 over x minus 3. So just like the previous examples we've done, we want to make sure that everything has a common denominator. I think it's pretty clear what we have to put on this. This one on the far left is already a-okay. It's got everything it needs, because really this one in the middle just needs to gain an x minus 3 on the top and the bottom. Now it matches the one on the far left. And this one on the far right just needs an x plus 4 on the top and the bottom. And now it matches the other two. And again, don't worry about the order there. Order does not matter when you're multiplying. So x minus 3 times x plus 4 is the same thing as x plus 4 times x minus 3. Hopefully you know it, but I'm just reassuring you on that one. So rewriting this now, it's going to be 5x minus 1 plus, because there's a plus sign here, I feel pretty confident just double dipping it through all in one step. This is going to be plus 3x minus 9 all over x plus 4, x minus 3. I just combined them into one here. See, I just did it naturally. I wasn't even thinking, but that's fine. Equals 1 times x plus 4. Let's be real here. That's just x plus 4 over x plus 4 times x minus 3. Next step, really important. Again, both denominators, both sides of the equation. Even if I hadn't plugged these and stuck them all together just naturally, you would see that both sides of the equation have the same denominator. So you can just cross them out completely and ignore it. I'll combine my like terms here. 5x plus 3x is 8x. We can minus this 1x over to get 7x equals, while we're at it, let's move all of our numbers over to the right side. We have 4 already over on the right side. We want to add 9, though, and add 1. 4 plus 9 is 13, plus another 1 is plus 14. So 7x equals 14. Divide by 7 on both sides. You're going to see x equals 2 as your answer. Last but not least, though, let's list our NPVs. We have x cannot equal positive 3 and x cannot equal negative 4. But the good news is with these NPVs, it doesn't match what our answer is. So in other words, our answer is safe and it's clear to go. Hopefully that wasn't too bad. Look, I kind of like hyped up at the title there saying meat's back on the menu. It's more like it was like, you know, like tofu's on the menu here. It looked like meat. It wasn't actually meat though. So we're all good. Anyway, let's try something else here. So something interesting may happen with this one. This one's kind of a spoiler at the top there. If you'd like, you can pause the video here, give this one a try on your own to see what interesting thing may happen. But aside from that, I'm going to go over it right now. So first things first, factor everything. One thing interesting right off the bat is look at this up here, 2x plus 2. You actually can factor something out of that. If you can factor something out, by all means, please do. You can actually factor out a 2. I don't know how effective that's going to be, but I'll try it anyway. That'll be 2 times x plus 1. And that we also have to, factor the denominator here. We're looking for two numbers with a sum of 2, but a product of negative 15. I think that would be positive 5 and negative 3. So x plus 5 and x minus 3. And now I feel kind of silly because, of course, you look at your other denominators here. It's kind of setting it up exactly what you can expect. So 2 over x minus 3 equals 1 over x plus 5. Clearly, we have to make all of our denominators match. This one's good to go because this one already has an x minus 3 and this one already has an x plus 5. So we can just add an x plus 5 to the top here and to the bottom here. And we'll stick an x minus 3 to the top here and an x minus 3 to the bottom there. Just because I think we're kind of getting used to this idea of, if both sides have the same denominator, you can cancel it. I'm going to do something a little different this time. I'm actually just going to cross out the denominators right now, just so I don't have to write them all over again. It's kind of, it's kind of a waste of time. And then I'll just multiply everything through on my numerators. So that factoring that I did in the very first step, it wasn't actually needed. So I'll just multiply back through 2x plus 2 plus 2 times x plus 5 is 2x plus 2 times 5 is 10 equals 1 times x minus 3. Well, that's just x minus 3. And then once again, let's just combine all of our like terms. I'm going to bring all my x's over to one side. So I'm going to minus x here. And then I'll move my numbers to the right side. So I'll minus 2 and I'll minus 12. This is going to give me 2x plus 2x, which is 4x. And then minus an x is going to give me 3x equals negative 3 minus 12, which is negative 15. And then minus 2. Did I do this correctly? Let me try that again. Hold on. Sorry. Minus 3 minus, why did I say minus 12? That's what I was doing there. What on earth? Minus 10. My mistake, guys. Sorry. Minus 3 minus 10 is minus 13, and then minus another 2 is minus 15. There we go. The reason I was kind of wondering, I was like, what the heck? That doesn't divide by 3. That's going to be messy. My mistake, guys. Sorry about that. Hopefully you caught that while I was going through it. Anyway, divide by 3 on both sides now to get x all by itself. And you're going to have x equals negative 15 divided by 3, which is negative 5. As always, though, we need to list our NPVs. So listing my NPVs just over here, we have x plus 5 as one of our denominator factors. So we have to say x can't equal negative 5. And the other one with x minus 3, we have to say x can't equal positive 3. Let's just repeat what we just said, though. We found the answer, x is negative 5. But then we looked at our NPVs and it says x cannot equal negative 5. That means that this x equals negative 5 being our solution doesn't actually work. So we actually have to cross this out because it was one of our NPVs. What this means is the only way that this is going to equal, this whole left-hand side is going to equal this right-hand side is if x were to be equal to negative 5. But if x were to be equal to negative 5, we'd have a divide by 0 going on here. So this is one of those weird questions. See, something interesting. This is one of those weird questions where we actually have to say no solution. And before you ask me later on, if you said, oh, somehow I saw this coming and I knew there was going to be no solution, do I even have to show my work? Yep, you do. You actually do have to show your work because you have to prove that there was actually no solution to this. We had to show that the solution would have been negative 5, which matches one of our NPVs being x can't equal negative 5. So this really lays out the importance of finding these NPVs. NPVs do tell you what your possible solutions are or not. So do make sure you're reading into those very carefully and checking any answers you get to make sure that they don't match one of your NPVs. Anyway, that's enough of me rambling for today. I think probably the only thing you want to work on is some stuff in your homework booklet. You can now complete up to question 4D. So there's a whole other page now that is able for you to complete. Be sure, as I just mentioned in the last question, check your NPVs. Make sure your NPVs don't match any of the answers you get, because if it does, you just have to cross out those answers and potentially say no solution. Anyway, aside from that, though, if you want a little bit extra practice, page 348, questions 2 ABC and 3 ABC and 6 AB. Those questions would be some good ones to work on. Aside from that, though, if you ever need any help, please reach out to me or ask me any questions, even in our classroom Zoom. Anyway, best of luck, guys.